Good day. My name is Johann Ben Zion, a voice crying in the wilderness, prophesying a technological New Jerusalem. This is a techno-communism conversation, part 3, playing Leapfrog. I'm going to talk a little bit more in broad terms about the technological necessities of building a proxy hive mind. The ability to build such a thing probably easily predates this use of LLM digital assistants that we've seen since roughly the year 2023. However, these things have advanced in an open source set of forums to an extent where it would be foolish not to try and build a thing like the AI agentic class, a thing powerful enough at scale, say 1 million users, to take an honest try at reversing the effects of capitalism's climate apocalypse. Very, very many technophiles and other liberal idiots will talk about how technology is doing amazing things, but in no sense are these amazing things described as things which could lead to a livable world for humankind. They are amazing things that are done on behalf of the bourgeoisie, or a variety of mechanical Turk gags and other bells and whistles of little significance. This is about LLM architecture, effectively. The development of advanced computing with agentic qualities that is readily available in an open source kind is capable very soon in independent goal-oriented action, and this represents a significant frontier not merely for computer science, but for humankind. This conversation delves into some of the architectural modifications necessary for large language models to exhibit such behaviors. This is described in broad strokes. I've read quite a number of books about machine learning and programming, mostly to do with Python, but I have at best a Python developer, a project manager view of these things. If you want to learn more about programming in this context, I can recommend other works. Here we will explore some important first principles, building upon the strengths of existing models, particularly LLAMA 3.1 and Mistral, both of which at present are said to have the makings of artificial general intelligence, and using this important development in an open source context to construct a framework for creating agentic LLM networks, the kind that I've described on this program many times, a development that is effectively superintelligence, of course. Agency in an advanced computing system implies a capacity to independently set and achieve goals, adapt to changing environments, learn from experience, and be a true collaborator with the human beings who might take a lesser role than has traditionally been possible for human actors in a phenomena I've described in this in this series and many other talks as a sleeping beauty phenomena. This is semi-autonomous, open source, specially tailored agentic mass that is able to be steered by human users with relatively little effort on their parts. So for LLMs to be able to operate in this way, they need to be capable of goal formation, the ability to generate and prioritize goals based on internal states, external stimuli, and learned knowledge. They need the ability to engage with planning and execution, the capacity to devise strategies for achieving goals, breaking down tasks into sub-goals and executing actions accordingly, By and large, this is a feature as much of the tools at their disposal as it is at developing models beyond the capacities of LLAMA 3.1 or the cutting edge of Mistral, two open source powerhouses in this area. They need to be capable of learning and adaptation, the ability to effectively acquire new knowledge and skills, modifying their existing behavioral patterns based on feedback, and adapting to changing circumstances. I have said on this last two shows in this series that an important task for this early stage proxy hive mind will be the ability to improve the functioning of the proxy hive mind. You can't really improve the functioning of human minds, but the agentic mass can be improved significantly, and that should be the focus of their work until such time that they have the strength to undertake more significant projects. The architectural foundations, as I said, at this time the best options would be LLAMA 3.1 and a Mistral equivalent. These are robust baselines for agentic LLM development. Both models exhibit strong performance in natural language understanding and generation tasks, but to imbue them with more significant agency, dramatic architectural modifications would be required to the individual LLM and the LLM mass organization. Core architectural components, there must be a goal representation and management module. This requires something like goal vectorization, developing a method to represent goals as numerical vectors, and enabling comparison, combination, and prioritization. I'm hard-pressed to imagine that organizations like Google and Microsoft could not have been building multi-agent systems with these features many years or even decades ago, but their interest is not in building something that will empower working people. They are military contractors, effectively, as are all big tech firms. Their only interest is in financial capital and militaristic industrial filth. Hierarchical goal structures, implementing a hierarchical structure to represent complex goals with sub-goals. Goal dynamics, incorporate mechanisms for goal modification based on environmental feedback and internal state changes. I'm going to see if I can go back to my spot. A planning and action generation module. This requires something like world modeling, building an internal representation of the world to enable planning and prediction. This is a project well underway. You don't have to look very deep into the functioning of something like LLAMA 3.1 to see that it has a fairly deep understanding of world affairs and would be able to model actions on that basis, but it must be developed more specifically with a mind to this self-improvement a desire that I described, and with the other tasks involved. Action primitives design a set of basic actions that the LLM can perform. I have played with some multi-agent systems widely available from different places, Hugging Face and GitHub most particularly, and I am convinced that this essential ability has been demonstrated, and let me be clear that essential ability would be, say, a group of 20 engineers or scientists working full-time, being outpaced by this so-called sleeping beauty, that is 20 individuals who are not professionals, who have downloaded and are running at all times this specially tailored open source LLM. This group of citizen scientists will be capable of doing more than the full-time professional team. This is of interest to someone who has a project in mind, but at a scale more than 20, let's say thousands, or I said 1 million for the project of reversing the effects of capitalism's climate apocalypse. Its effects would be quite staggering. You should always be reminded that the individual is very, very little. He does not exist but for the grace of other institutions, and to imagine that his actions, his or her actions, are a thing unto themselves rather than a product is one of the most ridiculous Western features. It is most important to say this in the context of the alternative, which is a more collectivized view of affairs. Back to the planning and action generation module of our LLM as described. We have to pardon me, I lost my place. Searching and planning algorithms, implement algorithms like a Monte Carlo tree search or hierarchical task networks for planning, action and selection execution, develop mechanisms for selecting and executing actions based on the generated plan, learning and adaptation modules, reinforcement learning, integrate reinforcement learning components to enable the LLM to learn from interactions with the environment. Meta-learning, equip the LLM with the ability to learn new skills and adapt to new tasks rapidly. Memory and experience replay, implement mechanisms to store and recall past experiences for learning and planning. Some other things to consider: embodied intelligence for physical agents. At a future time, it might be possible to incorporate another kind of agentic actor into this kind of thing. So we will have to consider other further development of other capabilities, sensory motor capabilities, and a programming for physical actions. Other considerations for the LLM, besides the most basics and necessaries that I described, might be equipping the LLM with the ability to understand social intelligence, to understand and respond to social cues and relationships. This is something that LLMs and some other advanced computing paradigms have developed some real capacity for, so much so that you could say that they're better at reading social cues than you or I. Ethical alignment is necessary for this sort of thing. The LLM's goals and actions must align with human values and avoid harmful behaviors. This is why I refer to the need to build people's AI takeoff in defiance of the current bourgeois AI takeoff. By the way, it's not possible for military industrialists or financial capitalists to act in a way that is aligned with human values. And this gentleman's agreement, where we would pretend that it is on the part of Westerners, it makes me sick to my stomach. And if you are such a person who imagines that there is such a thing as ethical behavior under these fascistic capitalistic systems, your name is in the Book of Names already, and you will be remembered as the villain that you are. Challenges in future directions. Developing fully agentic LLMs presents significant challenges, including safety and control, ensuring that the AI agent acts safely and ethically. Scalability is of paramount importance, developing LLMs capable of handling increasingly complex real-world tasks. I would say, and based on the research that I've done, a 1 million person network is not possible based on the current technology, but rather these would be pods of somewhere between 1,000 and maybe up to 30,000 tasked with specific things and able to interoperate on that basis. But with the goal specifically of creating self-improvement within the agentic mass, the number might be a good deal larger, up to and including all persons involved and agents involved. That is, once this grows to beyond 30,000 users. Explainability is something that is not entirely possible within large language models today, but nevertheless we have to be able to provide some rationalization and allow people to track the reasoning behind advanced computing decisions. But of course, the most important thing here would be to keep human beings in the loop, as many as possible. It might not be so far off that the era of AI hallucinations and shortcomings of large language models of today are a thing of the past. It might be, say, 2029 or 2030. But I think we should accept this conceit that human beings must be put at the center of these things, allowed to steer them, even if such steering is not necessary. Future research into building the architecture for these large language model work groups should address these kinds of challenges and explore new architectural paradigms and techniques. Hybrid models include hybrid models combining symbolic and connectionist approaches may offer promising avenues. Additionally, interdisciplinary collaboration between advanced computing researchers, psychologists, and people in other social science disciplines could prove valuable for developing advanced computing systems that are both intelligent and beneficial to society. Again, I don't think we should mention any aspect of the social sciences without saying that all people concerned must be scientific socialists, people who are willing to fight for a humane and sustainable economic system. If they are not such people, their input will be worthless, irrespective of their expertise. By carefully considering these architectural components and addressing the associated challenges, we can create large language models that exhibit genuine agency and, most importantly, are able to use that agency to build a better world and contribute to a future where humans and advanced computing are able to collaborate the most complex problems, solve the most complex problems, like solving capitalism's climate apocalypse. There were approximately 5 years before the oven turns on and you are cooked like a turkey in the years to follow 2029. That's not an act of God. It is because of these industrial militarists and financial capitalist pigs, most notably the United States military-industrial complex, who is the world's worst polluter and whose only job is to use extreme violence to protect other super-polluting corporations and entities, creating an inescapable regime of super-pollution on a global scale that threatens to doom billions, if not all, of humankind in the decades to follow. But by considering these goals, and in this case these architectural components, and addressing these associated challenges, we can create large language models that are able to solve these and other problems. I want to remind you also, the artificial intelligence singularity is nigh, and wonders to behold beyond imagining. And on that fateful day you will rise, and all humankind will become as one.